Hey folks, today I just want to go over a couple of problems in proving trig identities. So here's an example in front of you. And what I want to do is I want to transform the left-hand side to look exactly like the right-hand side. I'm going to choose the left-hand side because to me it looks like it's more complicated. There's more I can do with it. I'm going to choose that, but you can also choose the right-hand side and transform the right-hand side to make it look like the left-hand side. Now, I'm going to start with the left-hand side in the squaring. So I need to use the FOIL method, and when I use the FOIL method, I would get cosecant squared of x plus 2 cosecant of x cotangent of x plus cotangent squared of x. Now I'm not allowed to use any adding, subtracting, multiplying, or dividing to both sides of the equation. So I'm putting this barrier up, and I just know that my last line of work should look like the right-hand side, but I have to work completely on the left-hand side. Now we have a lot of trig identities here that could be transformed into sine and cosine. And if you remember in your past, the trig identities, reciprocal identity, for example, that's what I'm going to use right here. So I just used a reciprocal identity for cosecant. Now I'm going to use a ratio identity for cotangent, and I'm using that here. So remember your identities and then use those within your work. The next thing I need to do is just do the multiplication and addition. That's a square there. So I have 1 over sine squared of x plus, and on the top here I'm going to write 2 cosine of x, and on the bottom I have sine squared of x, and I have cosine squared of x over sine squared of x. Well, look where we need to go. Look at the right-hand side. There's no sine of x on the right-hand side, so I need to get rid of sine of x. I'm going to write 1 minus cosine squared of x on the bottom here instead of sine squared of x for the denominator. On the top, if you write that out, you'll notice that that looks very algebraic, and you can transform that into 1 plus cosine of x quantity squared over this guy 1 minus cosine squared of x. Now I'm looking ahead and I'm realizing that what I need to do is get rid of these squarings as well. So I am going to factor cosine squared of x into the difference of squares. Let me just erase this squaring here and rewrite the square as the product of 1 plus cosine of x times 1 plus cosine of x. And we notice then that we can cancel. I'll cancel 1 plus cosine of x, and ta-da! I have the right-hand side. So now I'll just clean it up and write the left-hand side so it exactly matches the right-hand side. All right, there it is. So your last line of work on the left-hand side should be what it says on the right-hand side duplicated down there. Okay, we're done with this problem. Okay, here we have a new problem, prove the identity, and we notice that the left-hand side is way complicated and the right-hand side is just the number 1. So it's really obvious we need to work on the left-hand side. I'm going to put a barrier up here right underneath the equal sign to remind myself I have to work only on the left-hand side. I'm not allowed to add, subtract, multiply, or divide to both sides because I'm not solving the problem. I'm proving an identity. I'm proving that the equation is true. So let's start with the left-hand side. I see that I have cosine of x, which is a main player in trigonometry. Now remember the other 3 functions, secant, cosecant, and cotangent, and sometimes tangent too, of course. What we want to do is transform them into sine and cosine when we're working with identities. So I'm putting parentheses down there because secant in the denominator should be replaced by something you know to be true by identity. And again, I leave sine and cosine alone. So I want to leave those alone and just transform by identity the functions like cosecant and secant that you see here. Now, think about the reciprocal identity. Secant and cosine are reciprocals. So I write the reciprocal identity in place of secant and cosecant. Now that I've done that, I need to now think about adding and dividing appropriately, and these steps will lead to the right-hand side, which is the number 1. So the next step is to divide, but when you divide by 1 over cosine, you are actually multiplying by the reciprocal. Again, when I divide by 1 over sine of x, I multiply by the reciprocal, which is sine of x over 1. Now we have a very simple expression here that I can just do the computation and write it as squaring. Well, this looks familiar. Oh yeah, it's the Pythagorean identity, and we conclude our problem with noting that the right-hand side is written as the last line on the left-hand side, and then you know we're done. Okay, I hope these examples help you with proving trig identities.